Salam and peace be upon you. We have walked a long way together in this journey, from episode 1 all the way to this moment. We started with the human hunger for reality, with 4 billion years of trial and error, with life as the first great experiment about what is really there. We questioned energy, we questioned space and time. We stood together at the point where almost everyone else stops and says, "That is the foundation." And we took one more step. We said, what if even energy, even space-time, are not the deepest layer? What if they are readings of something deeper? In the last parts of episode 6, we did two big things. First, we asked a dangerous question. If reality had a code, in the way books have alphabets and life has DNA, what would that even mean? We used words, music, rugs, and DNA to feel what a code really is. A small alphabet plus simple rules that can build endless worlds. Then we stripped the universe down to something almost absurdly simple. At every event, at every place where anything could happen, there is only a single angle on a circle. A quiet, cyclic rhythm. A phase. The holophase. We imagined reality not as a room full of furniture, but as a sea of tiny invisible dials, one at every event, each dial pointing somewhere around the circle. That pattern of angles, everywhere and everywhen, was our holophase field. Now we stand at the threshold of something even more subtle. If this holophase is so fundamental, why do we never see it directly? Why does the stuff that writes the universe never show its bare face? Why do we always meet it only in its differences and its changes? This part of our journey is about that question. We will explore, gently but rigorously, how everything we ever measure is, at its core, a comparison. How holophase fits into this relational world, everywhere, but never naked. Why this invisibility is not a weakness, but exactly what makes phase fit to be a universal code carrier. And how this forces us to ask only one kind of honest question about holophase. Questions about change, about derivatives, about how phi behaves when you nudge time and space. All the way through, I want you to remember something important. This model is not asking you for loyalty. It does not ask for belief. It does not hide from experiments. It invites them. If I am wrong, if this whole holophase picture is false, I want you and the entire scientific community to kill it. Not with anger or emotion, but with instruments, with data, with clear, simple logic. I would rather this model die young, under sharp investigation, than drift for hundreds or thousands of years as a beautiful but false idea that no one had the courage to test. So as you listen, do not switch off your scientist mind. Keep a little question burning in the back of your awareness. What would count as evidence against this? What would have to happen in a real experiment for me to say, no, this cannot be right? Hold that with you as we walk. Let's begin. Imagine you are standing in a pitch black room. No windows, no streetlights, no phone screens, just darkness. Then someone lights a single candle. Suddenly, a world appears. You see the contour of a chair, the outline of your hands, a faint glimmer of a wall. You feel as if your eyes are seeing light, but more precisely, your eyes are seeing differences in light. Your eyes are not very good at measuring absolute brightness. They are excellent at measuring contrast. If you place a bright patch on a bright background, it almost disappears. Place a slightly darker patch next to a slightly lighter one, and a sharp edge jumps out. An object appears out of nowhere. Your skin works similarly. It does not whisper, the temperature is exactly 23.54 degrees. It says, this water is warmer than you, or the wind is colder than your skin. Your ears do not report absolute air pressure. They respond to tiny fluctuations around the background level. compressions and rarefactions in the air, the changes we call sound. Even your sense of balance is comparative. It does not measure some abstract number for gravity. It feels changes in orientation, the start and stop of motion, the shift in acceleration when the elevator begins to rise or the car turns. We like to imagine that physics deals in pure, absolute numbers, perfect values etched into the universe. But in practice, almost everything we measure, even with our most precise devices, is comparative. A ruler compares one length to another. You choose some piece of metal and say, this is 1 meter, and all other lengths are measured in multiples of that. A voltmeter compares two electrical potentials and reports a difference. A clock measures time by counting cycles of some process you trust to repeat. The swing of a pendulum, the vibration of a crystal, the oscillation of an atom. Many quantities we talk about as if they were absolute are in fact only meaningful up to an arbitrary zero. Height above sea level. You chose the sea as zero. You could just as well choose the valley floor. The difference in behavior of rivers, winds, and rocks would not change. Time zones. Someone decided a particular meridian would be midnight zero. Shift the zero, and the world's events do not rearrange themselves. Electric potential. You can add a constant to the potential everywhere, and the electric field and currents remain the same. Only differences in potential matter physically. We do not live in a world of isolated numbers. We live in a world of relationships. Keep that feeling in mind, because Holophase lives exactly in that kind of world. When we say there is a phase value at every event, it is tempting to imagine some cosmic master dial. As if the universe had an absolute angle, and someone could say, right now the phase of the universe is 53 degrees. But no such single global phase shows up in any experiment. Physics never asks, what is the absolute phase of everything? It always asks, how does the phase here compare to the phase there? Let's make that concrete. Imagine a room with two speakers in it. Both are playing the exact same pure tone. At some spots in the room, the waves from the two speakers arrive crest on crest, trough on trough. The sound is strong there. At other spots, a crest from one speaker meets a trough from the other. The sound becomes very faint or almost silent. If you could freeze the air and paint each point according to how loud the sound is, you would see a pattern of bright and dark bands, stripes of loudness and quiet. That pattern is the physical shadow of phase differences. It records where the two sound waves are in step and where they are out of step. Now imagine you take the electrical signals driving both speakers and delay them by the same tiny amount. You have just added the same extra phase to both waves. Both dials have been rotated by the same angle. What happens to the stripes in the room? Nothing. The bright and dark bands stay exactly where they were. No ear, no microphone, no instrument can tell that you shifted both phases together. As far as the world is concerned, you did nothing. That is your first concrete clue. For these sound waves, and for many other waves, a uniform change in phase everywhere has no physical effect. Only differences in phase matter. The same thing happens with light. Think of the famous double-slit experiment. A beam of light shines on a barrier with two tiny openings, and a screen behind the barrier records a pattern of bright and dark fringes. Those bands are not magic spots where light decides to exist or not exist. They are a map of phase differences between light that came through the left slit and light that came through the right slit. If somehow you could take the whole incoming light beam and twist its phase by the same angle everywhere, The pattern of bright and dark fringes would stay the same. There is no physical measurement that can tell you that you have rotated the entire phase of the beam. Physicists call this kind of change a gauge transformation. You change some underlying quantity in a way that leaves all the actual observables unchanged. We do this in other areas of physics as well. In electromagnetism, you can add a constant to the electric potential everywhere, and none of the electric or magnetic fields change. In gravity, you can add a constant to the gravitational potential, and no forces change. In relativity, you can choose any coordinates you like. The underlying causal structure, who can influence whom, stays the same. Holophase behaves like that, but deeper. You can add the same angle to the holophase at every event in the universe. Rotate every hidden dial by the same amount. If the holophase picture is correct, no interference pattern, no wave speed, no physical outcome changes. The universe shrugs. If someone walks into the lab and says, I have just rotated the absolute phase of reality by 7 degrees, and nothing, literally nothing observable changes anywhere, then what have they really done? From the point of view of physics, the answer is simple. Nothing at all. This is what we mean when we say that holophase is gauge-like and unobservable in its bare form. Not because it is mystical or magical, but because any global shift of phase leaves all the truly physical quantities unchanged. What shows up on screens and sensors are combinations of phase that cancel out these irrelevant shifts, differences, gradients, rates of change. If this sounds abstract, remember, you already accept similar things elsewhere. You never worry about the absolute value of electric potential. You worry about the difference between 2 points. You do not care about the absolute zero of height. You care about the difference between the hilltop and the valley. You do not care where time equals 0 was set in a calculation. You care about the intervals between events. Holophase simply extends this logic to the deepest layer. The real underlying thing is a cyclic ordering at each event, an angle. But like height, like potential, many of its absolute values are invisible to physics. Only properly constructed differences and changes count. So is the holophase real or just a bookkeeping trick? Here, the model takes a clear stance. In this project, holophase is treated as ontic, as the actual substrate of reality. We are not saying it is just a mathematical convenience on top of something else. We are saying this is what truly exists at the fundamental level, but with one very important caveat. We accept, from the start, that no experiment can ever read out a single, absolute phase value and give it physical significance. Only relational patterns are real. If someone one day builds an experiment that measures an absolute phase, and that measurement has unavoidable consequences that cannot be rewritten in terms of phase differences and derivatives, then the holophase model is wrong. Not adjusted, not extended, wrong. And I want that to be true. If reality says no to this model, I want it to be a clean, sharp, decisive no. I do not want holophase to survive by hiding in the fog, by being so vague that no experiment can touch it. Keep that in your heart. This model wants to be killed if it is false. Now, let's sit with the paradox at the center of all this. On one hand, the absolute value of holophase at a point seems like almost nothing. You can shift it by any constant, and nothing in the world changes. The universe does not blink. On the other hand, the pattern of how phase differs and changes across events seems like almost everything. Once you know how phase varies from place to place and from moment to moment, you can describe an enormous amount about what waves will do there, how patterns will interfere, what can resonate, what can be stable. To feel this, imagine a landscape of hills and valleys. You decide to measure height above sea level. Someone else decides to measure height above the valley floor. A third person decides to call some random rock 0. Each of you gets a different absolute number for the height of a particular tree. But the shape of the landscape remains the same. The slopes are identical. The curvature is identical. The places where water will flow are the same. The paths a hiker would take are the same. The absolute choice of 0 height is almost nothing in physical terms. But the pattern of differences in height is almost everything. It decides where rivers form, where roads are easy to build, where cliffs will crumble. Holophase is like that, but on a circle instead of a vertical line. Pick any reference angle as 0. Rotate the entire phase field by that angle. The physical world does not notice. But the way phase values differ from one event to the next, the way they wind around loops, the way they twist in space and time, that is where the entire physical story lives. In music, the same principle appears in a different costume. Picture two violinists playing the same note. What matters to your ear is not whether they are aligned to some cosmic reference pitch. What matters is whether they are aligned to each other. If they are perfectly in tune, their waveforms match. The phases of their vibrations are aligned, and you hear a smooth, pure tone. If one player drifts slightly off, you hear beats, a slow pulsing loud, soft, as the phases slide past each other, sometimes aligning, sometimes opposing. If both violins rise together by the same small amount of pitch, maintaining their relationship, the music sounds the same, just a little brighter. Your emotional reaction does not care about the global shift. It cares about the relationships. Holophase is like a universal version of that musical story. The absolute angle of each dial is less important than how those angles differ. Where angles line up, waves reinforce. Where they oppose, they cancel. Where they twist continuously, vortices appear. Where they oscillate in a regular pattern, stable rhythms emerge. Absolute holophase is almost nothing because you can shift it everywhere and nothing happens. The structured pattern of phase relations is almost everything because it encodes the entire physics we can observe. This is why we will eventually say that the code of existence lives not in raw phase values, but in phase derivatives, in the organized ways that phase changes in time and space. But before we get there, we need to keep one more promise, to keep falsifiability at the center of our journey. It is tragically easy to build a beautiful picture that can never die. You declare that the ultimate substance is beyond measurement, that it cannot be captured by instruments, that it transcends testable predictions. That might be emotionally satisfying, but it is not physics. It is poetry. Poetry has its place, but this project is not allowed to hide there. So let me say this as clearly as I can. If someone designs an experiment that convincingly measures an absolute phase with physical consequences that cannot be rewritten in terms of differences and derivatives, holophase is dead. If a phenomenon stubbornly refuses to be expressed in the language of phase relationships and phase changes on any reasonable window of spacetime, that is evidence against the model. If two independent methods of reconstructing phase from the same physical situation give systematically incompatible answers that cannot be blamed on noise or calibration errors, the claim every admissible observable comes from holophase is in trouble. Later in this series, when we talk more technically about licensed windows and reconstruction pipelines, we will be even more specific about these tests. We will talk about using two different techniques like two independent translators checking each other's work. We will talk about quantitative error bounds and when a reconstruction is trustworthy. But even now, in this conceptual episode, I want you to feel that contract between us and reality. Do not protect this idea because it is elegant. Do not defend it because you like it. Test it. Attack it. If you ever work in a lab and you find reproducible data that contradicts Holophase, I want you to follow that data, not this story. This model is either the alphabet in which the universe writes itself, or it is wrong. There is no glory in keeping a wrong alphabet alive for centuries just because it is beautiful. Hold that as we move to the next step. If absolute phase is gauge-like and relational structures are all that matter, then what are the simplest, most honest questions we can ask about holophase? Imagine our ocean of tiny dials again. At every event, a hidden hand points somewhere on a circle. As a creature inside this universe, you cannot step outside and look at the whole pattern from above. You are always local. You can only nudge things and see how they respond. There are three especially natural kinds of nudge. First, you can stay put in space and let a tiny bit of time pass. You can ask, if I sit at this event and wait for a moment, how much does the phase dial rotate here? That is a question about how holophase changes in time at a fixed place. Second, you can freeze time, at least conceptually, and take a tiny step in space. You can ask, if I jump from this point to a nearby point at the same instant, how much does the phase change? That is a question about how holophase changes in space at a fixed time. Third, you can try to move in such a way that you stay on the same phase pattern. Imagine following a ridgeline of constant phase, like a surfer riding a wave crest. You can ask, in what direction and at what speed do I have to move so that the phase under my feet stays aligned? These are three very different feeling questions, but they are all about one thing: local change. You already experience versions of these in your life. When you listen to a sustained note and hear its pitch bend slightly up and down, you are sensing something like the first kind of change. When you walk around the room during a concert and feel the loudness of the sound swell and fade in different spots, you are sensing something like the second kind. When a surfer keeps position on a moving wave without falling off the back or sliding down the front, their body is solving the third question in real time. Mathematics gives these questions formal names: time derivatives, spatial derivatives, directional derivatives. But you do not need the symbols to grasp the idea. Once you accept that only differences and changes are meaningful, local rates of change become the cleanest summaries of what is happening. Return to our hillside. You could draw a complex contour map showing height everywhere. But if you're actually standing on the slope with heavy boots and a backpack, the key quantity is simple. How steep is it right here, and in which direction is it steepest? That steepest way up arrow is the gradient. If you knew the gradient everywhere, you could reconstruct the whole shape of the hill up to an overall vertical shift that changes nothing physical. Holophase is a landscape on a circle. Its steepness in time and steepness in space are its derivatives. They tell you where phase is spinning quickly, where it is almost still, where it changes gently across space, where it twists sharply, where patterns will be dragged, where waves will bend. These derivatives are not just convenient. They are, in a sense, the only legitimate questions we can ask holophase, if we take relational physics seriously. Everything else we talk about, particles, fields, forces, geometry, information, will be built from organized patterns in the answers to those questions. The beautiful, almost shocking thing is that your senses and your technology are already built around these questions, even if you have never used the word holophase. Your eyes are full of neurons whose entire job is to notice change: an edge appearing, a line moving, a flicker in brightness. Your ears are exquisitely sensitive to timing, to tiny differences in arrival time and phase between your two ears. Your brain uses these differences to locate where sounds are coming from. On the technological side, oscilloscopes show how signals rise and fall in time, making time derivatives visible on a screen. Spectrum analyzers decompose signals into different oscillation rates, telling you where the underlying phase is spinning faster or slower. Noise-canceling headphones create waveforms exactly out of phase with incoming noise and cancel them, exploiting phase differences to erase unwanted sound. Phase-locked loops inside radios and phones quietly track the phase of incoming carrier waves so your device can stay synced. Interferometers compare phases along two paths and turn tiny phase differences into visible intensity fringes. Holography reconstructs the full phase and amplitude of light across a surface so that depth and shape can be recovered. In all these cases, no one reads out an absolute holophase. They read out differences, rates of change, and patterns of how phase behaves relative to a reference. In a sense, your nervous system and your instruments are already speaking the holophase language. They are fluent in derivatives and differences. The holophase model simply proposes that we take this seriously, not just in special areas like optics and acoustics, but everywhere. If, as we apply this language, we find phenomena that cannot be described this way, that is a strike against the model. If, on the other hand, more and more parts of physics become simpler, cleaner, and more unified when rewritten in this language, then perhaps we are indeed learning to read a real alphabet of existence. So where does that leave us at the end of this part? We have a substrate, holophase, a phase at every event. We have a crucial property. Its absolute value is gauge-like, invisible to all experiments when shifted uniformly. Only differences and changes matter. We have a world, both biological and technological, that already lives by differences and changes. And we have three primitive questions we can ask holophase at each event. How do you change in time here? How do you change across space here? And how do patterns ride along you? Those three questions are going to give us our first line of code. In the next part of this episode, we will finally cross the line from essence to code. We will name the temporal rate of change of holophase, how fast the dial spins at a point. We will name the spatial rate of change, how phase twists as you move through space. And we will see how those two combine into something we can interpret as motion, the way patterns of constant phase move through the world. Time, space, and motion, which we once treated as three separate ingredients of reality, will reappear as three different ways of reading one local pattern in the change of holophase. That will be the first explicit section of the holophase code. And we will not rush it. We will take it slowly, patiently, step by step, episode by episode, until the full code stands in front of us, not as a slogan, but as a structure you can test, attack, and, if it survives, trust. Until then, hold this simple sentence in your mind. There is a hidden rhythm under everything. We can never see it naked. We can only see how it differs and how it changes. And in those changes, the universe writes its story. In the next part, we will begin to spell that story out, one derivative at a time. And as we do, I ask you again, do not protect this model from your doubts. Bring your sharpest instruments, your strongest evidence, your most merciless questions, and aim them straight at its heart. If they succeed, let it fall. But if all of that fails to kill it, if your best attempts only make it clearer, cleaner, more consistent, then we don't need to force belief. Truth is a resonant phenomenon. It will align with you, and you will quietly find yourself aligning with it.